Welcome. All right, so how do you simplify complex fractions? And when I think about simplifying complex fractions, I kind of focus on the fraction part of it. And that's what I'm going to kind of use to help explain how we're going to simplify complex fractions. Now, what I'm going to do is I'm going to provide you with kind of an arbitrary example. It's just going to have some variables in it, even though the problems in this course are mostly going to deal with some expressions, and we're going to have to simplify them and so forth. But I'll talk about that a little bit after, once we kind of get over the main idea of simplifying complex fractions. So I'm just going to provide an example here with AB over CD. All right, so you can see this is a complex fraction. I have a fraction in my numerator and a fraction in my denominator. So the first method that I like to do to simplify complex fractions is get rid of the fraction in the denominator. And the way that I'm going to get rid of the fraction in the denominator is multiply it by a number that it's going to equal 1. And to do that, I need to multiply by the reciprocal, which will be d over c. But remember, whenever I have a fraction, I'm multiplying a number in the denominator, I'm going to want to multiply that number in that same number in the numerator to produce an equivalent fraction, so I'm not changing the result. So any fraction multiplied by reciprocal, that multiplies to 1. And then here I can just multiply this over, so it's AD over BC over 1. Well, anything over 1 is just going to produce a final answer of AD over BC. So that is kind of example number 1. And I'm just going to kind of save that answer so we can kind of see what would be the example number 2. And the example number 2 is now, rather than just looking at the fraction in the denominator, I'm going to look at both fractions. And a lot of times when we're looking at fractions, we just want to get rid of what's in the denominator. We don't like fractions. So let's get rid of the denominator. So to do that, I can multiply each term in the numerator and the denominator by the LCD, the least common denominator. So I look at my two denominators and I say, all right, what's the least common multiple, LCD. What's the least common multiple of B and D? And you can see it's just going to be a product of BD. So I'll just write out to the side, the least common multiple of B and D is BD. Now I'll multiply both the numerator and denominator by BD. And I'm going to write BD over 1 because just BD is always over 1, but we don't really write it over 1. But it's helpful in this case, so you can see that it's in the numerator, not in the denominator. So now you can see that the b's are going to divide to 1. The d's now divide to 1. And I'm left with a simplified answer of a times d over 1, which is just AD, over, the c is still there, c times b over 1, which is just going to be c times b, which we can rewrite as bc. And therefore, you can see that we got the same answers. So now these two examples that I went over are very kind of basic. And when you're looking in through the problems, the most important thing is you can see that I have a fraction divided by a fraction. And that's exactly what you want to have. So in a lot of these examples, you're going to have like expressions. It's going to be a fraction minus another fraction, a fraction plus another fraction. So what you're going to want to do is combine the numerator, combine the denominator, so you have a single fraction in the numerator and a single fraction in the denominator. And once you have your complex fraction in that form, then you can apply by multiplying by the reciprocal of the denominator in the top and the bottom, or multiplying the numerator and the denominator by the LCD, least common denominator, or the multiple of both of your fractions. So there you go, ladies and gentlemen. That is how you simplify complex fractions. Thanks.